Let's do flashback long division. So Miss Wiz came up with this. I thought this was really cute. Okay, so Dad divides, Mom multiplies, literally, right? Sister subtracts, brother bring down, okay? And then somebody came up with, because then you have to start all over again, or I'll tell you in a second. Oh yeah, somebody, we'll just do it right now. Okay, so I'm going to show you, we're going to do that here. Then there's repeat, and somebody said, okay, huh? Somebody said rat, repeat, or doggy do-over. I guess they have a pet rat. Rat, yeah. You could, somebody could have a pet rat. Doggy, do-over, or rat. Ooh, rabbit repeat, and rabbits multiply. Oh, that might confuse us. Rat repeat. Okay. 5, 4, 3, 2, 1. I mean, how much more 6th grade math can you get, right? Okay. So everybody watch me. All right. So I'm going to go through this one pretty fast. So this is my dividend, because actually multiplication and division are inverses of each other, right? So when I multiply two things, I come up with an ending, which is my dividend. Yeah. Can you come back at the end of the period? That'd be perfect. Thanks, ladies. Okay, so 5, 3, 2, 1, 7. They all have their places. Let's spread them out a little bit. And this is my divisor. And when I divide 3, or if I divide my divisor into my dividend, the end result, I'm going to get a quotient. So quotient times divisor equals dividend. You don't have to necessarily know that vocabulary, but it's something that I'd like to reinforce. Okay, so 3 divides into 5 one time. 1 time, so that's the dad divide. Then 1 times 3 is 3. That's the mom multiply. Sister subtract. I don't say sister subtract. I say draw the line and change the sign. And it may not seem very important right now, but when we start getting into these polynomials that we're dividing, you're going to need the draw the line and change the sign and make you say it over and over again. Okay. So 5 minus 3 is 2. Brother bring down. Rat repeat. Okay. So now I have 23, and I'm going to ask myself, how many times does 3 go into 23? And it goes 7. So 7 times 3 is 21. Draw the line, change the sign. 3 minus 1 is 2. 2 minus 2 is 0. Brother bring down. Repeat, 3 goes into 21. 3, goes into 22. 7 times. 7 times 3 is 21. Draw the line and change the sign. I'm writing too big. I'm left with 1. Bring down. 3. We need another color. 3 goes into 11. 3 times. 3 times 3 is 9. Draw the line and change the sign. 2. Bring down the 7. 9. Pretty straightforward, right? If I wanted to check this, I could just take 17,739, multiply it by 3, and I should get 53,217. Okay. All right, let's make it a little bit more complicated. All right. Okay. All about the place value. And Miss Wiz, just as I suspected, I don't know whether I create this reality, but like a good handful of my kids want to do it on the side. Isn't that crazy? And they were like, I had Joe who said, Why wasn't I shown this before when I showed him how to do it within the problem? He's all, this would have been very useful. It's very weird. I know, that's crazy. Okay, hold on. Okay, so 45 does not go into 1. 45 does not go into 10. 45 does, however, go into 103. Let's do it with the blue. We're going to stay with the blue for the first time. It does go into 103. So that's what I'm going to concentrate right now, 45 into 103. Well, many of you with number sense can understand that 45 goes into 103 2 times. But if you don't know that, think about if it was 50. Isn't 50 pretty close to 45? Doesn't 50 go into 100 twice? So 45 must go into 103 as we're estimating about twice? Okay. If you didn't do that, or if you don't think that way yet, right, I could always think about covering up the last place value. So if I cover up the last place value, I do know how many times 4 goes into 10, right? 4 goes into 10 2 times. But I'm going to put it right here because that's what we're really talking about. Go ahead and remove my little spaces and start multiplying. 2, okay. So how many of you, raise your hand, would draw yourself some workspace over here, and you'd say 45 times 2. Okay. Only 1, 2, 3. Would you make yourself a workspace over here and do 45 times 2? Many of you? Okay. So it looks like we're about a third. Okay, I'm going to show it to you one time over here, but we're not going to use the workspace over here because actually my 6th grader came home with this, and I showed her teacher what you guys are going to be doing today. I put it on her homework on the back, and I said, this is why we do it all within the problem, and then she showed the kids the next day how to do it like this and not do it like that. Well, no, it's called vertical articulation, and it shows a 6th grade teacher may not realize that when you get to Algebra 2, right, that you're going to have all these steps you're going to have to do within the problem is going to actually confuse kids later on. Okay, so if I were to multiply it over here in the workspace, I'd do 5 times 2 is 10. What would I do with the 1? I'd carry it, right? Well, I'm going to do that right here within the problem. 2 times 5, right? This is my 1's place. This is my 10's place. So 2 times 5 is 10. What am I going to do with that 1? Carry it. Let's change the color. Carry it. And 2 times, isn't that the next thing I would do? 4 times 2 is 8. Carry the 1 is 9. So 2 times 4 is 8, plus the 1 is 90. Draw the line and change the sign. 3 minus 0 is 3. 10 minus 9 is 1. That's what I subtracted, so now I'm going to brother bring down, and I've got a 5. Start all over again. 45 goes into 135. Let's just concentrate on cover up the 5, cover up the 5, 4 into 13. How much is 4 goes into 13? 3 times. Start with the 1s. 3 times 5 is 15. Carry a 1. 3 times 4 is 12, plus the 1, 13. Draw the line, change the sign, and I have a remainder of 0. Okay, one question at a time. Okay, let's hear it, Philip. Okay, back to where? Yes, I started in the blue. I covered that up, and I said I may not know how many times 45 goes into 103, but if I cover up the 3 and I cover up the 5, I can figure out how much 4 goes into 10. I'm estimating, yes. 9, 0.9 times out of the time it's going to work. Okay. The only time it wouldn't work if this was 49, if it was 52. Why wouldn't it? How much is 52 times 2? 5 goes into 10 two times, right? How much is 52 times 2? 104. It's too big. So you see what I mean? If the number gets really, really, really close, it's not going to work, but that doesn't happen very often. If you go over, you just know, oh, it's not, I need to go one number down. Just like you do a normal multiplication and division, right? Okay, so let's try another one. Only, let's do it with that. Okay. Before, okay, I'm going to look at that. Okay. Now let's break it down. Let's use structure. Okay. Let's go back here and talk about it a little bit. You've already been doing something similar to what we're going to do today. You've already been multiplying, right, to get these numbers in here. You use the box method, correct? Okay. Well, so let's see what this works out to. If I multiply x plus 5 times x minus 5, I get x squared. Negative 5x plus 5x makes 0x. And negative 25. That's what you get. All right. Now pretend like we don't see this. Pretend like it's not there. Let's cover that. All right. So if I want to know these numbers up here, and I'm not really going to show you this method each and every time. I'm just going to show you where it comes from. Because somebody in that last class actually wants me to show them how to do it with the box. So we're just going to do it really quick. Okay, so if I have x squared, doesn't x go into x squared x times? Because x times x is x squared, right? Negative, I could fill this part in. Negative 5 times x is negative 5x. If I want these right here to add up to 0x, what must this be? Positive 5x. How many times does x go into 5x? Because 5 times x is 5x. Do you see how you've already been doing this? We're just doing the opposite. Right? Instead of saying 5 times x is 5x, we're just going to say how many times, what do I have to multiply by x to get 5x? So I need 5. 5 times x is 5x. Negative 5 times 5 is negative 25. Have you guys ever seen this? A multiplication table is actually a division table as well. Oh my God! How many times does 4 go into 12?
3 times.
What? How many times does 5 go into 55?
11 times.
This is really a big division sign. It's multiplication and division are inverses of each other. So you didn't see what the numbers were. So 3. Okay? It works with every number. Very good, Philip. Yes, I did. Okay. It does work with what we're doing right now. It absolutely works with what we're doing now, and that brings me to my next topic. Don't get scared by this stuff. Okay? Because all it really is place value. Okay? And this is why. Can I add x cubed? Can I combine x cubed and x squared? Does that make x to the 5th? This is why that doesn't work. If x cubed is in the thousands place, that's just like saying 6,000, right? And x squared is in the hundreds place, that's like saying 800. If I were to do like this, it'd be like saying this. Is that 14,000? No, you have to add by place value, right? So that doesn't work. You have to do this. You have to add by place value. So this doesn't work, right? It's just x cubed plus x squared. They have to have their own place. So if you just remember place value, you'll be okay. Stay nice and organized. Remember your place value. Actually, the long division almost becomes easier than long division with polynomials becomes easier because you have these exponents, so you know they have to be in the right place. If you have an x squared under an x cubed, you know it's in the wrong spot, right? Okay. Check this out. I'm going to cover this up because we all remember dad, mom, sister, brother, and the rat, right? Okay. The dog. You could say the dog. Was there a dog? What? The dog is Rover? My kids came up with one because they were upset that there wasn't Rover. Okay. All right, are we ready? Actually, I'm going to duplicate this page and then come back to it. Okay, so this is my dividend, my big number, right? So my big number goes inside my division sign. So it's x cubed minus 5x squared minus 4x plus 8. My divisor is my x minus 1, where this is my ones place and this is my tens place. This is my ones, my tens, my hundreds, my thousands. I'm going to make sure everything stays in the right column. I could almost do this. Make sure they all stay in the right column. It's not going to go further than that today. All right. So the first thing I'm going to ask myself is, it's almost like covering them up, right? Just like I did in the other one. I'm going to concentrate on this one. Let's change color. I'm going to concentrate on this one and this one, the first term. So how many times does x go into x cubed? Well, if you get confused on that, just ask yourself, how many times what times x makes x cubed? X squared. I'm not going to put the x squared here because is that where the x squareds go? No, x squareds are here in this column. So I'm going to put my x squared here. Okay, so that's daddy divide. So now we're going to mommy multiply. So x, first I'm going to multiply by my ones place. So x times x squared, times negative x is negative x squared. Would I put it here? Is that where x squareds go? No. I'm going to put it in my x squared column. So this is negative x squared. The only time I use signs are when it's a negative. I'm going to show you why right now. So that's my ones place. Now I got to do my tens place. And if I had a hundreds place of x squared, that would come next. And we're going to get there tomorrow. Okay. So x squared times x is x cubed. Okay, so that's my multiply. Now I've got to sister subtract, right? Draw the line and change the sign. Let me do it again. Y. Okay, first we divided, daddy divide, mommy multiply. What's our next one? Subtract. Isn't that subtracting? If I were to subtract x squared, doesn't that make it positive? Okay, one more time. If I said 4 minus subtract negative 2, what would that turn into? You see it? Florencia, she got it. Light bulb went on. Okay. So instead of saying subtract, I just say draw the line and change the sign. Because it makes me remember when I draw that line, what do I have to do? Change the signs because I'm subtracting. Okay? So now I've got negative 5x squared plus x squared is negative 4x squared. This is always going to cancel out if you're doing it right. What do we do after subtract? Bring down. Brother, bring down. Negative 4x. Rover, repeat. Rover, repeat. Okay, let's Rover redo. Yeah, we got that one. Okay, so now we're starting over again, right? So I'm going to find out how much x goes into or divides into negative 4x squared. Okay, if you don't know how much 4 goes into this, think of what times what makes 4x squared. Well, look, you need, if this is x squared, and I only have an x, I'm going to need another, and it's kind of a cheat. Look at, it's going to be the same as that. It always is. Always. If you've got it in the right column, right? Doesn't it have to come next? Okay, so does x times x make negative 4x squared? So what are we forgetting? So now let's try it. Negative 4x times negative 1 is positive 4x. And negative 4x times x is negative 4x squared. Sing it with me. Draw the line and change the sign. Okay? It's my song. Negative 4x and negative 4x makes negative 8x. This always has to cancel out, right? If you did it right, it cancels out. If it doesn't cancel out, you go back and say, I need to redo this, because this should always cancel out. Okay? Now we got to, brother, bring down. So how many times does x go into negative 8x? 8. Is that going to work? 8 times x is negative 8. Negative 8 times x makes negative 8x. So we're good. So let's do our ones place first. Negative 8 times my negative 1 is positive 8. Negative 8 times x is negative 8x. Let's do it together. Draw the line and change the sign. 8 minus 8 is 0. Negative 8x and positive 8x cancel out. You have a remainder of 0. So let's write this out. I'm going to finish this up. So what we're saying here, guys, where do I want to put this? Let's see. I know. Here we go. I'm going to do it right here in black. Everybody's attention. This right here, I'm going to rewrite. Okay? So x cubed is equal to, I don't want to put equal there though. Why? Thank you, Allison. It probably is that because it always dies about right now, huh? Thank you. All right. I'm going to rewrite it. How about here? Underneath it would be better. So x cubed minus 5x squared minus 4x plus 8 is equal to x minus 1 times x squared minus 4x minus 8. These two are the same. Now I could check my answer. By multiplying. Good job. Let's do it. All right, let's multiply. So if I want to multiply this out, I should get this. So what size box would I have? A 3 by 2. So I'm going to have x squared minus 4x minus 8 and x minus 1. You guys are being very patient on a very tedious process, and I really appreciate that. Well, we're going to do another one, okay? And then we're going to do another one, and then we're going to try and do another one. Okay, so x times x squared is x cubed. X times negative 4x is negative 4x squared. X times negative 8 is negative 8x. Negative 1 times x squared is negative x squared. I shouldn't hear you talking behind me. Negative 1 times negative 4x is positive 4x. Negative 1 times negative 8 is positive 8. This is all alone, so I just have x cubed. I'm going to combine my x squared, which gives me negative x squared and negative 4x squared makes negative 5x squared. 4x and negative 8x make negative 4x. And lastly, positive 8. Does that match this? Yes, it does. Let's graph it. Okay, so I know my y-intercept. My y-intercept is right here, and right here, and right here. So that's 0, comma 8. Please don't ever write my y-intercept as 8. Okay? That doesn't mean anything to me. That means that Mallory was 8 years old last year, right? It doesn't mean anything to me. Okay, so 0, 8 is right here. That point is 0, 8. I have another point. Where's my other point? One. Positive 1, right? I have a 0 here at 1. Show me what this graph looks like. It's cubic, right? So I don't have any other information than that, right? I can't find anything else at this point unless I were to plug in values, and we're not going to do that. We're not going to do a table of values. We're not going there. We're going to talk about just behavior of graphs. So I know my graph has to do something like this. So I'm going to say, oh, but it's got to cross there. So, well, I'm going to show you. So I start here, just like my graph, right? I'm going to start here. I know it's got to cross here. It may or may not be a double root. We don't know, right? We couldn't know unless we factored this further down. It could be a double. You want to pretend like it is? We could. That's all we know. Right? It could have gone down below that and come back up, but then it would be another 0 there, right? But all we know is 1, 0, so let's just make it a double root. Doesn't matter. All I really care about, okay, that's a really good question. We don't, well, can you factor that? Is it factorable? X and X, 4 and 2, negative 4, positive 2, does that work? Nope. 4 doesn't work. It's not factorable. How else could we find the zeros? What? We could complete the square. How else could we find the zeros? Quadratic formula, but we're not going there right now, right? Okay, we could use the quadratic formula, we could use completing the square, we could find our other zeros. We're not going that far today. This is all I want today. Let me show you where we're going. Guys, by the end of this unit, you'll be able to factor one of these polynomials all the way down, but we won't be using completing the square, and we won't be using quadratic formula. We'll be using square roots. We'll use square roots. It'll be very we'll either be able to factor it, it'll be something nice where we can factor, or it'll be something that we can use something like this. How would you solve that? Bring the 4 to the other side and what? Square root both sides. So that's where we're going. So, but today, all we're doing is dividing. The only reason I have a picture here is I want to make sure that we go back to remembering what we're doing here. We're dividing to find what? The roots, right? The factors. So x minus 1 and x squared minus 4x minus 8 are factors of that polynomial function, which is a graph that looks like this. Okay? Let's do another one. Actually, I'd love for you guys to get that one. Let's see. How's our time? We have 10 minutes. Thank you. All right, so we have 10 minutes. For those of you that want to write it in your notebook, you can write it in your notebook. I'm going to come around, I'm going to give you your homework, and I'm going to let you start on number 2 on your homework, and I want to get through number 3. So I'm going to give you about 3 minutes to get number 2 done. But I'll leave this up here. And I'm going to pause this. Caveat. Okay, when you're doing this, right here in the red, you can look at this like this. X squared times x minus 1 equals this, right? And do your multiplication there. Do you see how it's the same thing? And then this one in the pink would be negative 4x times x minus 1, right? Would be negative 4x squared. Is it in the right spot? Should be here. Positive 4. Yeah, it's right here, guys. It should be right here. This is why I didn't do this, because I don't do it this way, and I didn't want to confuse you. It should be right there. And then you draw the line and change the sign. That's why it doesn't look the same. That's another way that you, instead of doing your arrows, you could write it to the side here. Maybe I'll do the next one like that. Let's look at this one. I'm going to cover this up first. Yeah, because it's a long one. Okay. Start with the blue. Okay, how can you use this up? All right, so I have x to the 4th plus 2x cubed minus 79x squared plus 20x plus 100. That's my dividend. I'm going to divide it by x plus 10. I'm going to start off by saying how many times does x go into x to the 4th? It goes in x cubed, because x cubed times x is x to the 4th. And that's the hundredths place, right? Sorry, the tens place. Now we need to go ones place. Normally I would do the ones first, right? Doesn't matter. As long as you remember to put it in the right spot. X cubed times 10 would be 10x cubed. Looks like we did it right because look, it's all lined up. Cube, cube, 4th, 4th. Okay? It'll always be lined up. Now, do you see if I would have put positive when I draw the line and change the sign, it makes it hard to change the sign? So whenever I just leave it. So now I'm going to sister subtract, draw the line, and change the sign. Negative 10 and positive 2 make negative 8 x cubed. X to the fourth and negative x to the fourth cancel each other out. Bring down negative 79x squared. Yeah, and you don't have to do that, you just have to erase it. Okay, so now I'm going to go to my pink. So I'm going to concentrate on my x, goes into x cubed squared. Remember, Florencia? We know it's going to be x squared because it's the next slot right here. So it's going to be x squared, but not just x squared, because x squared times x is x cubed. What else do I need? I need the negative 8. Okay, let's start. Negative 8x squared times my ones place is negative 80x squared, and negative x squared times my tens place is negative 8x cubed. Draw the line and change the sign. 80 and negative 79 just makes 1x squared. This cancels out. Bring down 20x. How many times does x go into x squared? Should be x, right? Because x times x is x squared, and x times 10 is 20x. 10x. I'm looking at it going, I didn't mean to make a hole in this one. Sometimes that does happen, and we're probably going to see it tomorrow, but you're not going to see it tonight on tonight's homework. I'm going to draw the line and change the sign. 20 minus 10, hold on, you owe me a minute. 20 minus 10 is 10x. This cancels out. I'm left with, let's do orange. I'm left with x goes into, oh, I forgot to bring down. Bring down the 100. Change my color. Don't pack up or I'll make you unpack. X goes into 10x. How many times? 10. 10 times 10 is 100. 10 times x is 10x. Draw the line. And change the sign. Signs. This is 0. This cancels out. We're done. How do we check? Multiply with the box. I need to see checks as well. You don't have that many to do. You should be good. I'll have the answers online. Have a great day, guys.